Yeah, I'm Justin. So let me try this remote. So early this summer, I was playing with a project called Siri Proxy. And it's this gem you download, and you generate a certificate. You put that certificate on your phone, and you point the DNS from your phone to this server it starts on your computer. And you can actually use this DSL to intercept Siri requests. There's like a really cool DSL where you can look for certain parts of speech, and it will respond to it. And I was playing with this, and I thought this was like awesome. Like I could, at the time, me and my wife were looking to buy a house, and I had these dreams of being able to control like our entire house with my voice. And that seemed really cool. Unfortunately, this no longer works with iOS 7 because of some changes in Siri. But it still got me thinking, like, what else can I control from Ruby? Turns out lots of things. This is a Nest thermostat. It's a product you buy, you replace your thermostat with it. It has Wi-Fi built into it. It has a lot of cool features that it can like learn, but most importantly, it connects to the Nest.com API. And there's also an iPhone app and web page you can control your thermostat with. But it has an API, and there's a Ruby gem for it. So you can just require the Nest thermostat, put in your credentials, and then you can see the current status, temperature in your house, and the humidity, and you can set the new temperature. And that was like one of the things I was going to use from the Siri proxy. Another set of devices, these are from Belkin. It's called Wemo. On the left, there's a power outlet. The middle one is a motion sensor. And the right one is just like a normal light switch that you can replace. And these devices, the two on the ends, you can control from an API or from the internet or from your phone. And then the middle one is the motion sensor. You can actually set up triggers through their app or through a service called If This Then That. And you can actually make your house do things depending on external stimulus. Like you can even like connect these with If This and That, and like if I don't know, if you have like a Craigslist search for a certain item you want to buy, like turn a light on for me. I don't know. Basically, anything that has an HTTP API, you can talk to from Ruby. And so, like I said earlier, we didn't actually have a house when I was creating this talk. But I wanted to see like what I could do if I had all these things, and I was looking to like actually write a talk around this. And what I didn't realize is, once you get a house, you have like no free time to work on conference talks and open source projects. So what if I want to control things other than these packaged products like the Nest and the Wemo? There's a lot of like little devices. This is the Raspberry Pi logo. So there's Raspberry Pi and Arduino are two major devices that you can buy. Arduino is a very tiny, cheap device that runs a chip that you can run. I think I haven't actually played with one, but I think like C programming language, and I think there's actually one that has JavaScript that it can run. Raspberry Pi runs a full Linux install of Debian, so you can run anything you can run on a Linux machine, including Ruby, which is awesome. This is a Raspberry Pi. I actually have one up here. Hold on. This is a Raspberry Pi. I'm going to pass this around if anyone wants to see it. So there's all kinds of, it's like a normal computer. There's video and audio out. There's a USB port, and there's a Ethernet jack. And then also, on the one I have up here, there is you can just plug Wi-Fi adapter into the USB port. The one I have up here is like $8. And then the other really important thing on the left is this GPIO header, on top left of this one. Each of these pins, or not each of them, but most of them, you can set up to control external things. So each of these green pins, the GPIO ones, you can set them to be direction out, which means you're controlling something externally. And you can turn them on and off. And with that, you can control like anything in the physical world. You can also set them to be direction in and actually read events off of them. So if something happens in the external world, you can respond to it from within Ruby. So you need three things to use Raspberry Pi. You need a power adapter, which you could also just use any Android phone charger or Kindle charger, the Pi itself. And then an SD card is the hard drive of the Pi. That's the the Wi-Fi adapter I mentioned earlier. Some other things you might need, this is a GPIO breakout, which I have something similar up here I'm going to show you in a minute. But this allows you, if you're prototyping, working with the pins on the Pi itself isn't very easy, but if you can get those pins to this is called a solderless breadboard, where you can plug things in with these things called jumper cables. So it allows you to quickly change and prototype what your idea is before you kind of solidify it and make it again. You can, on the right, that's just any SD card. There's instructions on their website on how to download Debian and put it on this card. The one on the left actually comes with certain packages, and it's called New Out-of-Box System, also known as Noobs. The one on the right, if you download Debian and put it on an SD card, their distro of it, you can actually bring it up and SSH to it right away without any configuration. You don't need to plug a monitor. You don't need to plug a keyboard into it. The one on the left, a friend of mine showed me earlier this week. You actually have to like plug a keyboard and a monitor to it to configure it before you can actually SSH to it. So up here, I have a Pi here with the Wi-Fi adapter. And then I have this very similar to that GPIO breakout thing I showed you in the earlier slide. And this basically almost like an IDE cable connecting them. And then I have some things plugged into the breadboard, one of which is this LED. So I mentioned earlier we can actually SSH to the Pi. So now I'm actually on the device on the table. And I'm using sudo to run IRB, because if you do anything with the GPIO pins, you need to be root to do that. So I've already installed Ruby on this. You can just install it from apt-get. I'll show you that later, maybe. But I've already installed Ruby, and I've already installed a gem called PyPiper. There's two libraries that I found that allow you to work with GPIO pins. One's called Wiring Pi, one's called PyPiper. The Wiring Pi one seems to be a port of some C and Python stuff. The PyPiper one has a much more Ruby-ish interface, I find. So I like PyPiper. And so now that we've acquired PyPiper, we can create a pin. And this LED is connected to GPIO pin 4, the numbering I showed you earlier. And then besides saying which pin you want, you need to tell it to set direction out, or else it won't know that it's able to send a signal out. So now we have the pin, we can do pin on, and light turns on. And then we can do pin off, turn it back off. And then the first thing I did when I did that at home is I created this loop. Actually, I called it pin, didn't I? I created this loop so it turns on and off. Also up here, I have let me turn that off first. Also up here, I have this device called a relay. Now what a relay is used for is the voltage on the GPIO pins. Raspberry Pi, it's 3.3 volts out, which is fine for controlling like small electronics, but you might want to plug this into something with much higher voltage, such as your home electricity. And if you were to do that, you don't want to plug it directly into the Pi, because it would fry the Pi. So what this is a relay, and there is a power and ground, and then there are 4 GPIO connectors. And when you send a signal down those, it turns these relays on and off. It's very similar to in your car when you turn your turn signal on, that clicking sound is a relay from your computer telling the light to blink versus the actual higher voltage of the light turning on and off. And it makes the same clickety-clackety sound too. So these 4 wires that connect to this relay are on pins 18, 23, 24, and 25. The wiring of GPIO is a little weird, the numbering. So I have this code I'm just going to copy and paste and not actually type again. But I can take this array of those numbers and map it to a set of pins. And as soon as you set direction out, they all turn on. And then I have another loop, which I love. It makes that same clickety-clackety sound. And when I first got this up and running at home, I left it on for like an hour. It was awesome. So this is really cool. You can map that to turn them all off. It's actually on because it's reversed. So this is really cool. This allows me, like, as a Ruby programmer, anything in the awesome video RAM error. Anything in the video, anything in the physical world that I can connect to electronically, now I can control from Ruby. And I have a lot of ideas that I want to do with this, but I'll show you that later. And as I was creating this, it, like Seth before me, I love automation. I don't like staging environments with IP addresses and DNS names. I want everything to be automated and easily repeatable, and so I could in my house too. So I could take this in our house and set up pies everywhere, but like each one of those is going to have a separate code base. I could even like sync them with Git, but they're still all individual. And I'd probably write a lot of code that I'd write over and over again. So I wanted to create a library that that made this a little easier. So in the past few weeks, I wrote this library called Whipped Cream for Raspberry Pi. And what Whipped Cream is it gives you this DSL where you declare a set of things. I call these controls. So my canonical example is a garage door opener. So you have a button that you want to open, close, which is the same as pushing the button on your garage door opener. You might have a sensor, like a magnetic sensor, that tells you if the garage door is open or closed. And then you might have another switch for your light. And then you can run, start, and it actually starts a local Sinatra server that you can browse to on your phone, and it gives you buttons to control those things that you declared. So let me do that now. Yeah. So I have this file called pintest. And I just made it looking good, and I made a switch, which is the same, set up for the same pin as the LED as I showed you earlier. So now that's all set up, I can whipped cream deploy. That's the other thing I didn't mention yet. You can actually take this, test it locally, but you can also deploy it to your Pi. So you deploy, we're going to deploy pin test, and 1, 2, 3. Oop. Don't mind that. Cool. All right, so like I said, Ruby's already installed, the gem's already installed. But if they weren't, this would actually bootstrap your Pi to install these things. I actually wanted to use Chef for this, but there's no omnibus packages for Chef yet for the Raspberry Pi. If you are interested in why and want to help, come to me. So yeah, so that ran, it deployed, it actually started a daemonized Sinatra server on the Pi. So now, if we browse to that Pi's IP address, we now have this web page that I can browse to on my iPhone. And then if I control if I push that, the light turns on and turns back off again. So this is really cool. So I can like take this and put this all throughout our house, these different Pis that I want to configure for different things. So I mentioned the DSL had control. So I had 3 ideas for control so far. A switch is similar to how in IRB that I showed you, you turn the pin on and off. A button is the same thing, but it just does a momentary on, so it does on and then sleeps for a quarter second, turns it off, similar to like pushing a button in your garage door open or something else. And then also a sensor. I haven't played too much with this since I just finished that like this week, but in PyPiper, you can set up a thread that listens for events when you incoming, when a pin is turned on and off externally. You can actually bind that to a Ruby event and execute code. And then another thing is there's actually a camera that I have with me, but I still haven't had that set up yet either. But you can actually plug a camera into the Raspberry Pi, and there's a package called Motion, which you can install on your Pi, which will give you a video server on your Pi. So it'd be cool if you could just say in your DSL, camera, and then boom, you have a camera on your phone on your Pi. So it's that. This is all on GitHub and Justin Campbell /whippedcream. So I wanted to take a minute. I know we talked about TDD a lot yesterday. Means write your test first. So as I was writing this, TDD is something I've been trying to get much better at. So as I was writing this, I wrote all of this code. Of course, I opened IRB on the Pi, and I played around and got a feel for the libraries and what I wanted to do. But in writing whipped cream, I wrote all the code on the computer, and I wrote tests first, and then implement the functionality to make them pass. I did that for 2 weeks, and then I didn't run it on the Pi at all. And then when I took that code, copied it to the Pi, and ran it, it worked first try. So that was kind of like, for me, convincing argument that TDD can work really well. So shortcomings on this, there's absolutely no security. This is running in the bubble of my pass-protected Wi-Fi network. It would be cool if there was some kind of mutual like key or certificate or something between these devices. Yeah, no security. Location, I can only use this from inside my house right now, but it would be really cool if there was some kind of external service that these could all talk to that I could then access from my phone. Something better than like port forwarding. And then discovery. One idea I had was there's something called multicast DNS, which is the same as Bonjour if you're a Mac user. Devices on the same network can actually broadcast a name or a service that they provide. This is how AirPlay works from your phone. So it'd be cool if the whipped cream could actually advertise its name, like the garage door opener could advertise, I'm a whipped cream garage. And then other devices, like another Pi in your house, could then connect to that and vice versa. So you could have like this registry of Pis. And from Ruby, you could say, whipped cream, find garage, execute, open, close. That's something I want to work on. And this is still friction. This is still a little harder than I want it to be. It'd be really cool to automate some more of this away. But I have some ideas on what I want to do with this. Right now, like I showed you guys the garage door opener. I'm doing a lot of slow cooking meats on the grill. And it'd be really cool to have a grill thermometer to measure temperature and a meat thermometer to measure when meat's done, and be able to get notifications on when different thresholds are hit, and also maybe like even plot over time. I mentioned temperature in the grill, but also we have a split level house, which is 4 floors all kind of disjointed. And the temperature between the top floor and the bottom floor is about 10, 15 degrees. So it'd be really cool if I could like plot. A guy earlier this week gave me an idea of sending data to Google Analytics. I'd like to be able to plot temperature in different floors in our house, and then be able to adjust things about the air conditioning system and be able to see the graphs change. Another idea somebody gave me was a front door doorbell. So you could have a Pi with a camera on it. Somebody brings a doorbell, it could take a picture of them and then send you like an email or a push notification. Pet feeder. We have an automatic pet feeder and 2 really cute cats. And sometimes when we're on vacation, like this weekend, we worry that they, if they're getting fed. And we try to remember like the pet feeders on a schedule, and we try to remember to look at them when they're eating. But it'd be really cool if when the pet feeder dumped food out and then it like detected motion, it could take a picture and like show us that they were eating. Laundry, it could, if you could find some way to hack into your washer and dryer. You could like see when your laundry's done or if it's running or whatever. Garden, you could connect this to some kind of electrical valve to control water flow in your garden, and then you could water your plants depending on if it had rained recently or not. So that's all I have. If you want to come up and see any of this, feel free. And I'm Justin Campbell on Twitter. And that's it. Thank you.
That was awesome. We've got some time for questions if anybody wants to ask. If you want to take questions.
A couple things. There is a distribution of Debian by Adafruit, which is a hardware distributor called Raspbian.
Yeah, it's what's running on here.
Oh, you got that?
Yeah.
So that MDNS on there.
It probably does. I just haven't.
Yeah, so that should be on there already. And your gardening idea, that was my senior capstone in college.
Oh, wow.
We built out it watched the weather. It took in Zigbee to do moisture sensing around the yard to see if we should water or not.
Awesome.
That was using Atom board. You could do it way better with that. We were hoping that was available back then.
Do you have code for that?
Yeah, with C#.
What do you do when you want to give or receive messages from the Pi that have more sort of analog type data, like temperature and whatnot?
Right. So a big difference between the Raspberry Pi and Arduino is Arduino actually has analog inputs. However, some of the pins on the Pi, so I can find the slide. Oh yeah, sorry. The question was, how do you handle more analog things, such instead of on and off, how do you handle like temperature or other things? So I mentioned GPIO pins. There's a lot of other pin headers on this board, but on this header, there is this I2C, which I haven't played too much with, but as I understand is a protocol either similar to or is one wire, where, no, it's similar to. OK, thank you. But basically, I do have some thermometers I haven't actually plugged into this yet, but I do understand there is a way to, with basically almost like a serial bus, like just, yeah, like a serial bus, you can actually read data off of it. I haven't tried yet.
So a comment and a question. The I2C stuff, if you're looking into that, is a company out of Europe. There's actually one guy called G Labs, JEE Labs. He has a lot of sensors and outputs and whatnot that are I2C based. And they're distributed in America by a company called Modern Devices.
Awesome.
So, and they're very inexpensive. And he has a slew of variety. The question I have is with the whipped cream. So the Sinatra app, if I understand it correctly, is running on the Pi?
Yes.
Do you have kind of an idea in mind? You're talking about the garage door application, and I can follow through, that you're on your phone or browser to the Pi that's controlling the door, but having the wiring between two Pis. So you have a physical push button somewhere, and then send like a REST command to close the door.
Yeah, so the question was, could you have two Pis that were connected to each other and talking to each other over like the analog GPIO?
More over
Yeah.
GP.
OK, so the discovery thing I mentioned with, so the Sinatra app is, like I showed you, a web page, but it's also just a bunch of HTTP methods that you can, post methods that you can call from any other device. So part of the, when I mentioned discovery, I would like to make a portion of the library as a client to other Raspberry Pis so that you can find one without having to hard-code its IP address. You can just say, give me the left garage or whatever. And then it would be able to find it, and then it would basically be like a method missing, where anything you called on that, it would call remotely on the Sinatra server to do that.
So you have one Pi for each individual thing that you're controlling, and they've each got their own web server?
That's the thought, yeah.
And so you don't really have like a unified, this is my everything in my house?
No, but with that discovery, you could have each Pi's web interface could have a navigation to go to all the other ones in the house. So you wouldn't necessarily need like a portal to go to each one. You could just go to any of them and then get to any other one from that. When I first had the idea for all of this, I had very grandiose plans of doing this and have some kind of like management framework. But it seemed really, one, complicated, and two, I don't know if I really need it. But it would be cool to try. Next thing I want to do is add, instead of just the HTML output, is actually a JSON output of the current state of the Pi, so that you could aggregate that data somewhere else. So, all right, thank you.